Aloha, Richard Halverson here. This is ICS321, and it is spring semester Tuesday, January 26th. And so let me share my screen real quick here. Share screen number 2. And ICS321, this one. And if we look at the syllabus, I guess we're going to do video number 3 today. This is the week of January 25th, which was yesterday. And you are doing chapter 3 in date. So you're watching those chapter 3 videos, learning about foreign keys and so on. And we're also doing we're still in chapter 2 in zyBooks. So the quiz, the Laulima quiz, is related to the date book. And you know, it's been a long time since I've looked at these videos in resources, but let's see. Let me open up another browser to see what. So I'll open up my where's my Firefox. Oh. Hold on here. Here's my student, my student Laulima. This should look like yours. And when I go to, I just want to point out that when you go to resources, and these videos here, you know, there's enough consistency between semesters now that everything I've done, the solutions to everything are in a video. Okay, even the quizzes, the solutions are in a video, but the quizzes have been renumbered. They used to be handwritten quizzes, and I've transferred them to Laulima, of course. But anyway, so you can look at spring. This is spring 2020. I think there were a lot of good ones. Oh no, there weren't. I think fall 2019 was all the good ones. But anyway, I didn't really make any videos last semester, but I'm starting to make videos this semester now to try to refresh. And I like to make my videos worthwhile. So I like to do assignments and do quizzes, and so you sort of learn by, or you get help if you're stuck. All right, so if we go back to chapter 2, we covered sections 1, 2, 3, and 4. Oh yeah, 1, 2, 3, 4, and 5, I believe. Quite sure. Let me look and see what the spring 2021 video says. This is more descriptive. Okay, chapter 2.1 to 2.5 was video 2. So this is video 3. So let's start at 2.6, inner and outer joins. Okay, so you remember from the last section, we introduced the concept of a foreign key, and so you can have a table of employees, and then you get this other table of departments. And in the departments table, you got all kinds of information about the departments, like maybe the main department office, and so the office manager of the department, and the manager, the main or the chair of the department, and so on. And then you have employees, and then you have a code in the employees table that links. That's actually the primary key of a record in the department table, and that connects to all the department information. Well, What joins do is joins actually use that that primary key foreign key relationship, and you're able to make these virtual tables. You know, you're able to make a new table on the fly that's got a different defined set of columns that you want, and those columns come from those columns can come from more than one table. So the tables are joined together, and then you pick, you know, which columns you want from that table, and that's what joining is all about. But there's different ways of joining, having to do with what happens when a table row is missing. Okay, and so so that's what we're going to talk about today, and we're going to define these joins. So so with joins, you have a select, and then you have a left table and a right table. Okay, so the type of join that you do defines how the tables are matched up, and what happens if one side is missing or the other side is missing. Okay, so let's say we have departments and we have employees, and we want to list. Well, let's just see what this does. Yes. 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 No department for Sam Sneed. That's the problem here. So it doesn't print out. There's no manager. There's no employee matching up with technical support. So that doesn't print out. Okay. So so that was an example of an inner join, because the only ones that were printed out were ones that were where there was a match on both sides. See, it did not print out Sam Sneed. It could have printed out Sam Sneed and then just have a blank over here. And it could have printed out technical support and just had a blank over here, but it didn't. Okay. For a left join, you would have printed out technical support, but wouldn't have printed out the employee. And for a right join, you would have printed out Sam Sneed, but you wouldn't have printed out you wouldn't have printed out Sam's. For a right join, your the records on the right will always show up, and then it's whether or not a left join. Left is this side. Okay, so for the left join, okay, right. So for a right join, all the records on the right table will show up, regardless if there are matches to the left table. And for a left join, all the records on the left table will show up regardless of whether there is a match for the right table. For an outer join, they'll all show up, or both sides will show up. For an inner join, only the matched sides will show up. All right, which columns can be compared in a join? Well, okay, what this says is it doesn't have to be only the primary and foreign keys. It can be any keys. Okay, so so any columns. Oops. Oh, got to be comparable data types. It's got to be that one. So you can't have one column be an integer and the other column be a string, and those don't match up, because those don't make sense. They have to match up. So the data types have to be the same, and there can be a difference between the brand of SQL database, because in Microsoft SQL, if it's a varchar doesn't match up with a varchar 50 does not match up with a varchar 25. But in MySQL, a varchar 50 can match up with a varchar 25. So anyway, in a join, what are the first and second tables in the from clause? I think it's this one. Yeah, I don't use just writing the tables first and second table. I always specify what type of join it is, explicitly specify what type of join it is, and what the columns are in each table that I mean to connect, and that way it's fully documented. What's missing from the join statement? Select that, from that, where. Oh, right. Yeah, right. You have to have you have to say something about the relation between a column in here and a column in here. This is a column in here, and this is a column in here, you see. Okay, so that's the answer. No column from department appears in the, oh yeah, salaries, got it. Okay, yeah, it's that one. Whoops. Uh-oh. Oh, oh. Oh, no, oops. Yeah, I read it wrong. Yeah, this is talking about the select clause. Yeah, that's right. It's this one. A column from employee is not compared to a column from department. By the way, I will open up my chat in case anybody has a question here. All right, so that's joins. And so here we're defining inner join, left join, right join, and full join, outer join, full outer join. Okay, so an outer join is any join that selects unmatched rows. Okay, so so that's sort of a general term that we won't really use. We'll use we'll use left and right, and just join. Join is usually just inner join. Okay. Anyway, inner left written with the keywords like that as the animations below. Okay, so there's animations. Okay, so you can click on this and you can see how they match up and what the result is. See, the full join there's a null there because there's no employee for manager for technical support, and there's a null here because Sam Sneed, there's no Sam Sneed. There's something wrong with Sam Sneed's record. There is no Department 5384. No, wait. No. What? Wait. What was missing from Sam Sneed again? Oh, that Sam Sneed is simply not a manager. That's right. Maria is a manager, and Lisa is a manager. And so Sam Sneed is just an employee that's not a manager. Okay. So anyway, right. Okay. So that's why there's nothing here, because this is actually departments and managers, the managers of the departments. So anyway, okay, so here's an example of a participation activity which we have to do, and I guess I've done this already. All I did was click on run. But so we have a create. But by the way, this is pretty cool. This actually executes. What would happen if I were to say, professionally trained authors. Wait, is there a CLA? No, wait. I want to change something that we select everything from song and genre. Oh, okay, I know what I'm going to do. I'm going to change that, and songs, and it's an inner join, so they have to match. So we do have two GRU and RAB. Okay, so what I'm going to do is I'm going to make Old Town be a RAB. See if this works. Oh, it works. This is pretty amazing. I mean, this is just my browser here, and it executes this create table. Okay, how about if I do create table genre? Genre is I'm just gonna make something up that's stupid here. I'm gonna do city, whatever, city, whatever, 200. Then I'm gonna say Honolulu. And I'm gonna Los Angeles. It's RAB. Okay, here. Okay, so now when I run this, what's going to happen? It's amazing. Huh. Is there a MySQL engine or is there an SQL engine in the browser? I don't know. Written in JavaScript? There probably is. Okay, anyway, so that's interesting. And you know, of course, you can take this code and open up your PHP MyAdmin and go into a database and open up an SQL window and just paste this whole thing in there, and that should execute also. So I might show you that some other time. Okay. Here's another participation activity, which tests your understanding of right, left, inner, and full joins. And I guess what it gives you is two tables, and it gives you results, some results here, and you're supposed to guess. Okay, I'm not even going to look at anything, but this right here has got to be a full. Okay, because we got nulls on both sides. A full, that's got to be full, and this one's got to be a right join. It's got to be a right join because there's nulls on the left. And this has got to be a left join because there's nulls on the right. And this has got to be an inner join because there's no nulls. And there's nulls down here. All right, anyway, that's easy. So what's next? Special cases equijoin. See, I think compares columns of two tables with an equal operator. Most joins are equijoins, and so when we're, you know, connecting the columns, we want equal values, right? I mean, art matches with art, but it doesn't have to be equal. It can be not equal. It can be non-equijoin, and where you can use greater than or less than operators and so on. So anyway, that gets kind of complicated, and but anyway, so here's an example of when price is greater than max price, or when price is less than max price. It does a join with these anyway. So you can look at that. I've never used it. Okay, self join is when you're joining with yourself, I presume, and that's where you have. Here's an example of where when some employees are managers and so you have the manager, Lisa Ellison's manager is Jiho Chen, I guess so. Interesting. Okay, so yeah, and you would want to use an alias. You have to use an alias because you need to be able to refer to the separate to fields separately. All right, so yeah, see, so so here you're listing names, but in one case you're listing the name of the employee, and the other case you're listing the name of the manager of the employee, which is a link back to, which is the same table. It's the name in the employee table, but anyway, it's it's identifying a different um, attribute. Okay, cross join is when you don't really have a there's no on clause, so you aren't matching any tables. You're just, or you aren't only, you know, concatenating or merging records with the same value in a field, the same values in a field. It's you aren't doing that. You're just taking all combinations. So, you know, an iPhone is an example of that, where you may have these, you know, what's the cross join of the iPhone model and the memory options. It's all combinations. All right, so what's next? View tables. Okay, views are pretty cool. Views are like, instead of storing the table, you store a select statement, because a select statement produces a table, right? You identify the columns in the select clause, and you know, the rows are you know, come from some expression involving other tables, but so views are handy. They're a way of storing. Where's a nice list of reasons here why views are handy. They protect sensitive data. So instead of the table, you give a view, and a view is just like a table. You can join with it. You can do selects on it, but it's not really a table. It's a select statement that produces a table. So it's good for saving complex queries. You know, you work out that query and you don't want to forget it, and you want to use it often in the future. You just create a view, and then it's nice for storing optimized queries also. So here's how it works. And by the way, in one of your assignments, you have to create views. Can't remember which one. In one of these assignments, it might be assignment 2. You're creating views. Ah, yes, you're creating a view. Creating lots of views. So it looks like this: create view and a view name, and I'm not sure what this is. As, and then you put your select statement there. So I assume this is, you're selecting a projection, you know, from all the fields in the that come out of the select statement. But so here's an example of, you want to create a view called manager view, and what manager view is it's a table, and it's a table that can be recreated every single time if you simply execute the select statement. This is selecting the department name and the employee name, but you're renaming the employee name, you're renaming it manager name, from the join of department and employee on manager ID equals employee ID. So you have this department table and this employee table, and you join them together where it's all the fields where the manager ID is equal to the employee ID, those matching fields, and you end up, okay, and you're only going to look at department name and manager name, or you're only going to look at department name and employee name. And by the way, that's this field and this field. Those are the only two fields you want out of there. And in fact, you're going to rename this field. You're renaming it manager name. But anyway, so every time this select statement is executed, this table is produced. And so you create a view, and then any place where you would use a table, you can use manager view. And that's because of what's the term, that date, it slips my mind what the term is, that closure. It's because of closure. Closure is important. All right, so refer to the following, create view statement and view table. So here you got a couple of tables, and faculty and department. So it's a bunch of faculty people, a bunch of employees, and the departments that they're a part of. And so you're going to create a view, and you're going to the view is actually, oh, were we supposed to fill these in? I guess so. So what is the name of table A? So it's create what is the name in table A? What are we going to name the view? Oh, it's this. It's that. Right. Okay. What is the name in table B? As select faculty name, and it's faculty name, and we're going to call it professor, I guess. Right. And column C is, and then this is going to be assignment. Math department name. So it's department name is this one. Department name is going to be referred to as assignment. Okay. So anyway, you can fill those in. Querying views. Okay, so here's where it says that you can use a view in a query, as a table in a query. Is there? Okay, right. I gotta make sure this doesn't start playing here. All right, I had to. Aloha, this is Richard Robertson, ICS321. Sorry. All right. I had to edit the last class I taught a few hours ago. I started the video, and I didn't have the sound on. No, I didn't have the speakers on. Okay, it turns out I had it plugged into my headphones, and so I had to cut all that out. And whenever I have to edit a video, it's pretty quick editing. I use Microsoft Photo. It's great for editing videos, but it really takes a long time to produce the final video at the end. So it takes about 2-3 hours to produce the final video, and it only takes me about a minute to do the editing. Anyway, so here is an example of using that, where this is the view, and what this does is it produces this table called manager view. So it produces this table here, and the user is just saying, select the name of the manager of the sales department. So you select the manager name of the sales department. So select Lisa Ellison's name. And so so what's produced from this query is this. This is a result of the query. Now, it'll tell you, it tells you that it merges the query. It merges this query with this query. Yeah, whatever. But to me, this is a prime example of closure where this is the query. The query is select manager name from manager view, and manager view is actually this thing. Okay. And in fact, you could put this thing right here. You know, you can put parentheses, this thing, and then end parentheses. And then you have to say some name. You have to give it some name, because every resulting subquery's got to have a name. But you know, that's all that is. So this merged query, just, you know, you can spend some time figuring that out and seeing how it's merged, or you can just think about it in terms of using the closure property of relational algebra, which says that any operation on a relation produces a relation. Okay, so anyway, so here's some nice querying views using the views, defining and so you can go through this, make sure you understand concepts here in making queries or making views. Now, I didn't really get this where they talk about updating views, and they talk about how you know, you may be using a view as a relation or as a table, and you're embedding it in your select statements and using it and all that. But then somebody comes along and they want to do an update on it, or they want to do a delete from it. I don't see how that's you know, I don't think this would be valid in all programming languages. Yeah, I mean, in all versions of SQL, because these operations, update and delete, are on actual, you know, physical tables, not expressions of tables, you know. So it's like well, so I don't think it's very important to this is very important, but you need to go through the participation activities to get all the points. You should probably do that. So let's see what this does. Table views are commonly used in select statements, but using views to insert, delete, and using views to insert, update, and delete statements in those statements is problematic. Primary keys: if the base table primary key does not appear in the view, the insert to the view generates a null primary key value. Aggregate views. You know, I think you should just try it. Go to MySQL and try it. All right, that's something I'm going to come back to. Let's see, it's 3:07. There's not enough time for me to whip out an example on MySQL. But let's see what this says. Reroute. Okay, so this is the view query. It's select that as difference in department. indicate whether the following queries are valid. Well, let's just go through this and see. And we can learn by getting the wrong answer. You're inserting into the accounting view the department name. I don't see how that's valid. It's not valid. The insert does not specify a primary key. Oh. If it did, would it work? Let's see. Update account view, set difference equal to 440, where the code is equal to comp. Code is comp. Update difference to update this, change this to 440. I don't see how that can work too, because what is it? Okay, I don't think this is valid either. I could be wrong, but not valid. Update account view. Set department name equal to that, where comp is, okay, so account view, department name, updating the department name, and the code is comp. Okay, this might work. This might work because it's specifying a key, and it's not using, okay, all right, I'm going to say valid. The update specifies the primary key, so the base table row is clear. The update changes the department name column only, so the change is unambiguous. Okay, great. Delete from account view where department name is equals history department. I don't think so, because you're not specifying a key. Oh, where clause clearly indicates the base table, the row should be deleted. Okay, it does work. No, yeah, I guess this is a valid way to, this would be, okay, so you're just using this to refer to the department. Okay, all right, very good. You know, I wouldn't recommend this, but I guess you can do it. All right, the check option clause. Databases that allow view updates. So that allow view updates. Okay, so we have to go in there and see if MySQL allows this stuff. Phase one bothersome behavior. Okay, a view insert or update may create a row that does not satisfy the view query where clause. In this case, the inserted or update row does not appear in the view table. Right. So you might insert something into a table, but when you do that, it doesn't satisfy the view query where clause, because the view query where clause says, all right, so you do an insert, and you know, it inserts it back in some table that the query uses, but then that the view query uses, but then when the view query executes, it doesn't use that row that you just added to that table. So that can be like it fails, but it really didn't. And so check option, with check option, the database rejects inserts that does not satisfy the view query clause. Okay, that's good. I just would not recommend using using inserts and updates on views. Okay. Anyway, I'm gonna see where are we? It's 3:30, and I don't want to go past the scheduled time here. So we're in chapter 3. We're still. This is Tuesday, January 26th. That's this week. Next week, we're going into zyBooks chapter 3. Okay, so and chapter 3 is 2 weeks. All right, so I'm going to talk a little bit more. I mean, I want to talk a little bit more about these normal forms. I didn't get through Boyce Cod, And I think I'd like to talk a little bit more about 4th and 5th. So I'm going to do that next week. And so as we go along here, if I need to add another day to a week, then I'm free to do that with my new way of scheduling. So remember to go to here and make sure you keep your schedule up to date. And I changed the domain name. Please keep up to date when you can sit in a class, and so I can sit in. I registered cansit.in, can sit in, and so type in your UH, username and password, and so this was my schedule for this week. This is this class today, and so next week I'm not going to do anything on Monday for next week, but then the week after, my Mondays will open up again. So anyway, so I hope that helped. And so right now we are just doing zyBooks because there's no videos on zyBooks, and so I'd like to focus mainly on the videos there, and make sure that you get all the points for zyBooks. And there's other videos for the other ones too, but I might do some more videos on the quizzes because those are getting kind of old. Anyway, are there any questions? Anybody have a question? All right. Well, I will see you next week then. Thanks for watching.